Our goal is to understand how to calculate outliers. Outliers are bits of data that are really big or really small. They are untypically large or small. They're extremes. They're beyond what the rest of the data seems to be doing, either at the bottom end or at the top end. So you might have seen outliers before, and you might have used just some basic means for identifying them just visually, and you might have just, as your opinion, said, yes, this bit of data here is an outlier. I can see that it's not near the other bits of data. But we're looking at mathematical means for calculating outliers. So you can actually do it quote unquote properly mathematically. Now this is one method. There are others. One possible method involves looking at the median and the interquartile range and doing a calculation, or two calculations actually, involving these things called fences, which we'll get to in a minute. So we're going to learn this via example. So let's look at the example. The following data set represents the number of occupants in the cars driving down a suburban street over a particular hour. And there's our data set there. Now we realize, because we're going to use the median, we need the numbers to be in order. So we've got 13 numbers there, and we need to rearrange those 13 numbers in order. So here we go. 1, 1, 2, 3, 3. Oh, no, there's another 2, sorry. 2, then 3, 3, and then 4, 4, 4, 4, 4, 4, then 5, then 6, then 7, and then 18. And just double check, have we still got 13? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, we have 13. So let's follow the instructions before we get too carried away here, because I know what's going to happen, but I still got to follow the instructions. Determine the range first. Okay, the range is the largest number minus the minimum value, and that would be 18, take 1, which is 17. The range is 17. Now, compared to the size of most of the numbers there, the average might be somewhere around 4. That range is big. It's relatively big. So that means maybe there's an outlier, but that's only a supposition. What about part B, the interquartile range? So we need to find the median, the lower quartile, and the upper quartile. Now that's in order, we find the middle. So where is that middle? Well, if we go n plus 1 over 2, it'll locate the middle for us. N is 13, so that's 14 over 2. It's the 7th data point. So 1, 2, 3, 4, 5, 6, 7. So 4, it is on the actual 4. So we now have a lower set and an upper set. So the lower set does not include the median, as we know from our previous work, neither does the upper set. The median is like the pivot point on a maybe seesaw or something. Okay, now we've got the median. The median is 4, so we'll write that down. Median equals 4. Now we've got to find Q1, the lower quartile. So that's the middle of the lower set. So we've got, we could do it visually because the data set's pretty small, or you could go 1, 2, 3, 4, 5, 6, 6 plus 1 over 2, which is 3.5. So it's between the third and the fourth. There, it's halfway between 2 and 2, which is amazingly 2. And Q3, the upper quartile, we find it is between the third and fourth there in the upper set, based on our previous work. This is stemming from a previous work we've done already on this. It's halfway between 5 and 6, so that's 5.5. So 5.5. So we can find the interquartile range now. The interquartile range is, as we know from our previous work, the upper quartile minus the lower quartile, which is 5.5, take 2, which is 3.5. So we have an interquartile range of 3.5. Now the final direction, the outliers, if any exist. So we've got to find if outliers exist. Now this is the new part for this video, so pay attention. What we have is these things called fences. Now the fences are basically just like a fence on a paddock or a block. They tell you where the boundary is. And fences, there's an upper and a lower fence. So upper and lower. And what we do is the following. Please take this down. The upper fence is calculated by going Q3, or the upper quartile, plus 1.5 or 1.5 times the interquartile range. Whereas the lower fence is calculated by going Q1, or the lower quartile, minus 1.5 times the interquartile range. So let's do that for this data because we have all those figures. So we have 5.5 plus, oops, that's not a plus. Now that's a plus. We've got 1.5 multiplied by the interquartile range, which is 3.5. And we calculate that. And I get 10.75. Now for the lower fence, we go Q1, which was 2, minus 1.5 times 3.5. We calculate that, and we get negative 3.25. Now, what that negative means is that that's not going to be possible value for this because we have discrete data here that is only going to be positive, because we have the number of occupants. So the nature of the data, there's no way it's going to have negative. So we can tell straight away that the lower fence is going to be lower than all the data. Let's mark it in anyway. So I'll get a color I haven't used yet. Get this darker green. And let's mark in where the fences would go. So 10.75 would be there, in between those two values somewhere. All right, just vaguely there, and negative 3.25 is below the 1. So with those dark green zones, so what data is within the fences? I'll mark that in here in this leery purple color. All of this data here, stop at the next fence. So everything except for the 18, okay, is in there. So I've marked in the two fences, and that tells us then where we might find any outliers. We do have one. All right, we have one there. It's 18. Okay, so our outlier is 18. Sometimes, I mean, this one is fairly obvious because it's an easy example, but sometimes it is much harder than this to just look at data and say that's an outlier. Because yes, you probably could have used a pretty crude method and gone, yeah, that's clearly way beyond the others, but you never know, there might be others that don't stand out as much and you need to test for them. So don't just take it for granted that anything you just look at, oh yeah, that's an outlier, that's not, because sometimes it's more subtle than that. So you do need to calculate it with a lot of data sets. So we write our answer, therefore 18 occupants is the outlier. There's only one in this. Sometimes there's more than one outlier. Okay, is the outlier. So it's quite extreme compared to the other data. Now there's a little bit more to this here. It says if outliers exist, they do. Suggest a possible. So suggest a possible reason for this. Was it human error? Now human error is a common cause for outliers. Somebody pressed the wrong button, or didn't measure something properly, or somebody perhaps lied on a survey. You know, there's all sorts of things that can go wrong. We have to check that it's not that. If we can check it and we can verify no, it's not actually an error or a lie, we might still choose to accept the outlier. It's just a freakish event, or just an unusually big or small value. It does happen sometimes, but being able to identify whether an outlier is human error or not is important in a lot of our pursuits. So let's suggest the possible reason. So the context is we've got cars driving down the street, and let's look at our data here. Well, you know, we see a lot of cars there with just the driver, so that would explain the 1s and 2s, 3s, 4s. Yeah, most cars can carry 4 people, 5 people. Okay, we've got a smaller number of cars here, 6, 7. Well, yeah, larger cars have 6 or 7 seats, possibly even a partially filled minibus. What about 18? All right. So you'd probably want to perhaps it's a bus. It's a reasonable one. It might have been a sporting team or a big bus or a council. If they included you know, council buses or private buses, it might be a bus. You probably want to check that, because counting 18 people as something's going past, is that really possible? Okay, it must have been going slow. You might want to check that, but there is a plausible reason. It could be a bus, but you know, is it possible as something's driving by to count 18? You'd have to check that out. So it all depends on the situation. But anyway, that's how we find outliers mathematically. At least it's one common method of doing that, which involves the median and the interquartile range. We've also explained how fences are used in order to identify our outliers.